So we are starting the final section of Unit 5, which is on graphing inequalities. And it's really easy. If you remember y equals mx plus b, graphing lines with y equals mx plus b, this is going to be a piece of cake because it's done the same exact way. So let's take a look at this class opener and practice graphing lines with y equals mx plus b. You need to be able to recognize that the y-intercept, the b value in this case is -3, and it crosses the y-axis at -1, 2, 3. So let's put a dot right there, -3. So we know our line's going to pass right through that point. It might be kind of steep going down, maybe kind of steep going up, maybe really steep going up. How could you tell the steepness of a line? By looking at the slope. And the slope happens to be rise 1, run 2, right? So from this red dot, you're going to rise 1 and run 2. And you're going to get to this next red dot. And you could continue with that pattern of rising 1, running 2, rising 1, running 2 to get to the next dot, and so on and so on. You could even go backwards. Instead of rising 1, running 2, you could run 2 in the opposite direction and drop 1. Run 2, drop 1, and get that point right there. Then from there, you just draw your line, and you are done. So draw a line right through those dots, and you're done. I hope we remember this, right? This all came from y equals mx plus b, where the m is the slope, the rise over run, and the b is the y-intercept. You always start with your y-intercept, and then you rise and run according to your slope. The rise could be positive, could be going up, or it could be a negative rise going down. That all is determined by if this fraction is a positive value or a negative value. Because it was positive, from this point to that point, I did go up 1 because it was positive. If it were negative, it'd be going down 1, right? Anyway, let's try another. This one crosses the y-axis where? What's the b value of this next one? 3, that's right. So let's all go to 3, put a dot right there at 3. The b value is 3. What is the m value? Yep, the m value is 2. You could say 2 over 1 if you want for a rise over run. Now, when you're at this red dot and you want to see how the line passes through, how steep it is, it's this steep. Rise 2, run 1. Now, if you're at this red dot and you rise 1, 2, you're going to be off the graph. But who cares? It's only 1 unit off the graph. Run 1 this way, you're off the graph. Let's put a dot right here that's 1 unit off the graph. Put a red dot better. Okay. Now, if I were to draw my line, that's just going to be from here to there, and like that's a super tiny line. We know that the line is infinite, so let's just extend the line this way with this same pattern of rising 2, running 1. So go in the opposite direction, run 1 in this direction and down 2. Run 1 in this direction and down 2. And you could continue with that pattern to extend the line as far as you want. And of course, draw your line right through it and you are done. Put some arrows on it. That line is infinite, going in both directions. Here's a review question. What does this line actually represent? What does this line actually represent? I mean, it does have a slope, the rise over run, that's true. But like, this line is composed of an infinite amount of points, right? Like you have the coordinate -2, 1 right here. You have the coordinate -1, 2, 3, -3, -3 right there. You have the coordinate -1, 1, right? We have all these points. And all of these points are technically solutions to the equation. Like if I were to plug in a -3 for x and a -3 for y, -3 right here and a -3 right there, 2 times -3 is -6, and -6 plus 3 is -3, which would be that one over here, right? And that would be a true statement. So any one of these points, and it does go to infinity, right? It keeps going this way forever, this way forever. So any one of these points will give you a true statement on the line, and any point that's not on the line will be a false statement, right? That's what a solution is to an equation. A solution are the values that make it a true statement, okay? So if I were to plug in 0, 3, I'm sorry, not 3 zeros over here. 0, 3, this coordinate right here, let me write down 0, 3. That means if I plugged in 0 for x and a 3 for y, it will be a true statement. 0 for x, 2 times 0 is 0, a 3 for y, it'll say 3 equals 3, true statement. Anyways, that's just a review question. It is something that's important to know. that a solution to an equation are the values that make it a true statement, and we draw the line to be able to graph those infinite amount of answers that exist. That's why we have arrows on it, because it does continue forever. Anyway, number 3, if we wanted to graph this one, this is in standard form, ax plus by equals c, and you could find the x-intercept and the y-intercept. How do you find the x-intercept? You set y equal to 0 and solve. How do you find the y-intercept? You set x equal to 0 and solve. This is from the past, but I say let's just stick with slope-intercept form, especially for what we're doing today. So you could just rewrite this standard form into slope-intercept form. Get the y by itself. So the first step would be to get rid of that 3x by subtracting 3x. And what you do to one side, you do to the other. Then you rewrite this thing. It's a negative 2y equaling a negative 3x and then plus 6. And for my final step, I need to get rid of the multiplication of negative 2 in front of the y. So you're going to divide by negative 2, divide by negative 2, divide by negative 2. Final slope-intercept form equation will be y equals. We know that a negative divided by a negative is a positive, so we're going to leave it as a positive 3 over 2, because 3 divided by 2 you can't really do. And we do have an x right next to it. And over here, the b value, 6 divided by negative 2, that's a negative 3. So the b value is negative 3. And now it's ready to graph. Okay. Where does it cross the y-axis? What's the b value of this equation? Negative 3. Okay, so let's put a dot at negative 3. From that dot, what do I do? Rise 3, run 2. Rise 3, run 2. Because it's positive, we are rising. If that would have been negative, we'd be dropping. Okay. Anyways, rise 3, 1, 2, 3, run 2, 1, 2. Put a dot right there. And of course, if you wanted to extend the line even further, you could continue with that pattern of rising 3, running 2. And rise 1, 2, 3, and run 2, and you'll be right here at that dot. And then connect your dots, and you have your line. Well, that's a crooked line, but you get the idea. Last one. The last one, we have a point slope form equation, and you could identify the point, and you could identify the slope, and then go from there, or you could change it to slope-intercept form. I say just change it to slope-intercept form. Actually, I'll do both ways just to show you, right? So changing it to slope-intercept form, we want y equals, we don't want the plus 2, we want y equals mx plus b, we don't want parentheses. So to get rid of those parentheses, you're going to distribute first, 3 times x, 3x, 3 times 1 is 3. We do have y plus 2 equals that 3x plus 3. And to get rid of the plus 2, you're going to subtract 2 and subtract 2. So we now have our slope-intercept form equation. Y equals, the slope is 3 with an x right next to it, and the b value is a positive 1. Okay. So how would I graph that? Well, you start with your b value of positive 1 and put a dot on the y-axis at positive 1. And how does it cross right through this dot? You got to look at your steepness, which is 3 over 1. So you go up 1, 2, 3 over 1, and you could put a dot right there. And there's your line. You just draw a line right through it, put an arrow. If you wanted to extend it in the other direction, just keep going with that same pattern backwards of up 3 over 1, go backwards over 1, down 3, over 1, down 1, 2, 3, and put a dot right here. And then extend it this way. Now, we didn't have to change it to slope-intercept form. I recommend this method, but we could have technically said this is in point slope form. And I hope we remember that point slope form is y minus y1 equals m parentheses x minus x1. So you could actually identify a point recognizing the x1, y1. And the x1 is right here, but the original point slope form has a minus in front of the x1. So you have to think opposite of what you see here. So that would be a negative 1 for the x1 value. And then for the y1 value, it's a positive 2, but you should have a minus in front of it, so you think opposite of what you see here, and that would be a negative 2 for the y. So there's a point, and of course your slope is in front of the parenthesis, which is 3. So if I just wrote that down, slope is 3 over 1. Then you could graph it by going to that point, negative 1, negative 2. There's that point, negative 1, negative 2. And from that point, you rise 3, run 1. You would rise 1, 2, 3, run 1, and you'd end up with the same line anyway. Okay, so you don't have to do both methods. I would probably just stick with y equals mx plus b, but you could have identified the point and the slope because it's in point-slope form. Anyway, a couple more things we should review before we move on to today's lesson. Number 4, graph x is greater than 2 on a number line. I have a lot of lines right here. You don't have to fill them all in. How about this? Let's put the number 2 in the middle, and then let's skip every other one. So let's go 3, 4, and backwards it would be a 1 and a 0. And the question is, x is greater than 2. Is that going to be a solid dot or an open dot? Open dot. And do I go to the left or to the right? To the right. This says x is greater than 2. Where are the numbers that are greater than 2? Over here on the right side, right? So where is x is greater than 2? It's over here. You would draw an arrow that way. If you're still confused about which one's greater than, which one's less than, think about this. This arrow, this inequality has a point on the right side of it, so it has to point to the right. If it had a point on the left side, it would point to the left. So on this other one, number 5, let's put a number 3 in the middle. And going to the right, we're going to make it grow. 4, 5. Going to the left, we're going to make it less. 2, 1. And this guy right here will be a solid dot. Why? Because it has a solid line underneath it. So it's going to be a solid dot at 3. Fill in that dot. And is it to the left or to the right? To the left. Why? Because it has a point on the left side. This says less than. Less than's to the left, greater than's to the right. I hope we understand that, yay? All right. That was visual. How about when we read it? See if you understand. Number 6. On a horizontal, that means left and right, x number line. Yeah, of course. Left and right is the x number line. If x is less than a certain value, then the area you're talking about is to the left of that value or to the right of that value. What do you say? To the left, that's right. If x is less than is to the left. So your answer is A. Everybody should circle A right there. Greater than, if it would have said x is greater than, then that would be to the right. Less than's to the left, greater than's to the right. And that makes total sense because up here we do have an x number line. And it says x is less than that value 3. Which values are less than 3? The 2 and the 1, it's to the left. Greater than would be to the right. Let's take that a step further, but apply it to the vertical number line, the y-axis, the y number line, okay? On a vertical y number line, if you have y is less than a certain value, then the area you're talking about is above that y value or below that y value. What do you think? We haven't really dealt with that, but it's pretty simple if you think about it. This is your y-axis. Here's 0, 1, 2, 3. Let's say you're at 3, and if I said y is less than 3, well, then what would that imply? That it's an open dot up or an open dot down? What does less than imply? Down, obviously, right? 2 is less than 3, 1 is less than 3, 0 is less than 3. Up here would be greater. So right here it says on a vertical y number line, if your y is less than a certain value, then the area you're talking about is below that value. Below that value. And here on this example, you'll be going down this way. Y is less than 3. Here's 3, less than is below. Greater than would be above. Okay? So I hope you understand that. Less than on the x-axis is to the left. Less than on the y-axis is below. Greater than on the x-axis is to the right. Greater than on the y-axis is above. Okay? These are all the essential skills that you need to be able to graph linear inequalities. Okay? So if you did understand these first questions on the class opener with y equals mx plus b, it should be really easy to graph inequalities. Step 1 would be to do what we just did on the class opener, rewrite the inequality in slope-intercept form. In case you forgot, that's y equals mx plus b. Once you have it in y equals mx plus b, but of course you don't have an equal sign, you're going to have an inequality. You might have a less than or equal to, a greater than or equal to, or a less than or a greater than instead of the equal sign. Okay. Now, Step 2, once you rewrite it in slope-intercept form, is to graph it, but determine if it's a solid line or a dotted line, okay? Obviously, if it had an equal sign, it would be just a solid line and you'd be done. But right here, you got to determine if it's a solid line or a dotted line. If it has a solid line underneath the inequality, like a less than or equal to, or a greater than or equal to, that will be a solid line. But if you have something like a less than or a greater than without a solid line, that's going to be a dotted line. Okay, so as we read step 1 and step 2, let's actually go to this first question down here, or this first inequality. Step 1, rewrite it in slope-intercept form. Is it already in slope-intercept form? Yeah, y equals mx plus b. Okay, step 2, graph it, but determine if it's a solid line or a dotted line. Well, how do we graph it? Just like before, the b value is -1. That means it's going to cross the y-axis at -1. Let's all put a dot at -1 right there. And from that dot, I'm going to rise and run according to my slope. But this happens to be a -1/4. So what do? Go up 1 or down 1? -1/4. I want to go down 1 and over 4. Okay, so we're going to end up right here at that location. Now, if you wanted to, you could use the pattern backwards. Instead of down 1 over 4, go over 4, up 1, over 1, 2, 3, 4, up 1, and put a dot over here. That way you get your line from one side of the graph to the other. Now, here's the next step. After getting in slope-intercept form, which was already done for us, we need to determine if this is going to be a solid line or a dotted line. What do you think? It's going to be dotted because it does not have a solid line underneath the inequality. If it had a solid line, it would be a solid line. Kind of like before, over here, it did not have a solid line, so it was not a solid dot. Over here, it did have a solid line. It is a solid dot. Same thing over here. If it does not have a solid line, it's not going to be a solid line. So I need to put a dotted line right here. So everybody go ahead and do a dotted line right here. Like just put some dots between those dots. Put some arrows. Now, we need to shade. Okay? That's the next step up here. Step 3 says decide what side of the line to shade by testing any point that's not on the line. 0, 0 is the best choice if it's not on the line. Okay? What do I mean? How do you test the point? Plug it in and see if it works. So the idea is this, guys. If it were an equal sign, it would be just a line. But it's an inequality, and when we talk about inequalities, we talk about a whole area of answers. I mean, if you think about x equals 5, that's just the number 5. But if I say x is less than 5, you're talking about all the values that are less than 5, like 4, 3, 2, 1, -1, all those values, right? So right here, we also are talking about an area on the xy plane. All of the answers are either going to be above or all the answers are either going to be below. So it's either above or below where the answers are at. And that's why we graph to represent all the answers. So what we're going to do is test a point. Okay, I could pick any point I want. Okay, like for example, I could pick the point 4, 3. I don't know if I did that. Let me just pick 4, 1, 2, 3 right here. That's a coordinate 4, 3. If I test the x value being 4 and the y value being 3, and I plug it in right there and right there, and if it works, if it gives me a true statement, then I know that this is an answer. That means that all my answers are on this side of the line, so I would shade in everything up here. Now, if I test 4 and 3 into here and here, and it doesn't work, it gives me something false, then that means that this is not an answer. That means that all the answers are down here, right? So if I test 4 for x, 3 for y, this is what it would say. It would say 3 is less than -1/4 times x, which is 4 minus 1. And working this math out, -1/4 times 4, that'll be a -1. And then you have the -1 that comes down with a less than symbol and a 3 right there. And that is a true statement. 3 is less, no, that's a false statement. 3 is less than -2. That's impossible. 3, a positive number, is not less than a negative number. That's false. So what does that tell us about that actual point? That it's not an answer, right? It doesn't work. That means that none of these points up here will work. By the way, I just randomly picked 4 and 3. There are easier numbers or easier points to pick. The easiest number, as it says on the instructions, is to pick 0, 0. Because it's really easy to plug in a 0 for x and a 0 for y. could even do it in your head. Plugging in a 0 right there, that would make this 0. A 0 over here, it would say 0 is less than -1. So if I did test 0, 0, it would say 0 is less than -1, and that's false. 0 is bigger than any negative number. So this is not an answer either. So obviously, none of these are going to be answers. Where are my answers going to be at? On the other side of this line. So that's why we're going to shade everything that's on this side of the line, not up here on this side of the line. That means if I were to test any point I want down here and I plug in the x value and the y value of that point, it will work. It will be a solution. So why are we shading only the bottom? The detailed explanation is that any point down here, like if I pick, let's say the coordinate -4, -2, -4, comma, -2, and I actually plugged in the x value of -4 and the y value of -2, if I plug that in right there and that in right there, it'll give me a true statement, okay? So any point down here will work, and that's why we shade it in. After all, why do we graph? To represent the infinite amount of answers that exist to an equation. In this case, we're graphing and shading to represent the infinite amount of answers that exist to an inequality, okay? We already tested 0, 0, it didn't work. We already tested 4, 3, it didn't work. None of these points will work up here. All of these points will work down here. And that's why we shade to represent all those infinite answers that do work for that inequality. Yay? I know it's a long one, I apologize. Moving on to number 2, let's graph this one using those steps. First, rewrite it in slope-intercept form. It's easy, it's already done for you. Then graph it. This is your b value, this is your m value, and you can put it over 1. So it crosses my y-axis at -2. Let's all go to -2, put a dot right there. From that dot, I'm going to rise and run according to my m value, according to 4 over 1. So you're going to rise 4, 1, 2, 3, 4, over 1, put a dot right there. And you could continue to rise 4, but you'll be 2 units off. But anyways, before we draw our line through there, we need to ask, will it be a solid line or will it be a dotted line? What do you think? Solid line or dotted line? Solid. Why? Because it has a solid line underneath the inequality. So it's going to be a solid line going right through those dots. Okay? Now, in addition to that, you need to shade. Okay? So we need to test a point. What's the easiest point to test? We just did it over here. We tested 4, 3. That wasn't the easiest. The easiest is 0, 0, right? So if I test this point right here, the point 0, 0, 0 for x, 0 for y, and if it works, then it is a solution. That means that all the solutions are going to be right here. If it doesn't work, that means that all my solutions are on the other side. Okay? So when I plug in a 0 for y and a 0 for x, that's going to say 0 is greater than or equal to -2. Is that a true statement or a false statement? That's true. 0 is greater than any negative number, right? So this point right here, that works. That means that all of these points work, okay? Now, if you're confused with that, let me show you a shortcut. And you're going to love this shortcut, okay? Let's go back to number 1. I know we haven't finished number 2, but let's go back to number 1. You see, when y is by itself, and we're going to make sure that y is by itself. When y is by itself, you could think of the graph in terms of the y-axis, up and down, right? This says y is what? Y is what? What does that say? Less than. On the y values, is less than above or is less than below? It's below, right? So just by having y by itself and it being a less than, I know I'm going to have to shade below the dotted line. So you don't actually even have to test 0, 0. Okay? Let's look at number 2. We haven't finished shading. We did test 0, 0. We already know it works. We know we're going to shade in the top. But let's pretend that we're just going off of that rule that if y is by itself, you could use this symbol to determine if you're shading above or below your line. So what does it say? Y is what? Y is what? Greater than or equal to, right? So greater than on the y values is above. So if you go to any point on this line, let me go to this dot right here, this red dot, and I want to go greater than on the y, which way would that be? It'd be above. So all you have to do is shade above that line. And obviously that's going to be above, it's going to be above, it's going to be everything on this side. So you would shade everything on this side. Make sense? So it's actually even easier than the original method of testing points. Now, you're probably thinking, then why the heck did you even bother testing points on number one, Salgado, right? I tested it just to get you to really understand what we're doing here. We're representing the infinite amount of solutions. And what are solutions? There are those points, like the value -4, -2, that if you were to plug in, it'll give you a true statement. That's why I showed you this. But the quick and easy way of doing it is once you have y by itself, if it's a greater than symbol, you're going to shade above. If it's a less than symbol, you're going to shade below. Okay, so today, all we're learning, like we already knew how to graph in terms of y equals mx plus b, there's just 2 extra steps. The extra steps are, is it a solid line or is it a dotted line? And then after that, do I shade above the line or below the line? Okay, so let's take a look at number 2. That is in standard form. I recommend changing it to slope-intercept form. Let's do that. Subtract 3x, subtract 3x. Rewrite this thing, -2y is greater than -3x plus 6. You don't want the multiplication of -2 in front of the y, so you're going to divide by -2, divide by -2, divide by -2. Now, hopefully there's a little alarm going off in your head right now, because we're dealing with an inequality and we're dividing by a negative on our last step. So what does that mean that I need to do? Change the sign. That's right. So yes, y will be by itself, but the greater than has to change to a less than, because that's the one difference between solving an inequality and solving an equation, that if you multiply or divide by a negative on your last step, you flip the inequality symbol. And yes, we divided by a negative on the last step. So continuing on, a -3 divided by a -2, you can't really divide 3 by 2, but we do know that a negative divided by a negative is a positive. So at the very least, I can make this look a little nicer by making that a positive 3/2, putting an x right next to it. And the b value over here, 6 divided by -2, that is a -3. And now it's ready to graph. That inequality is y is less than 3/2 x minus 3. So it's going to cross the y-axis at that b value of -3. So you're going to go down to 1, 2, 3, put a dot right there at -3. Now from that dot, I'm going to rise 3, run 2, because it's a positive fraction in front of x. If it were negative, I'd be going down, but it's positive, so I'm going up. Up 3, 1, 2, 3, over 2, 1, 2, put a dot right there. And you could continue to go up 3, 1, 2, 3, over 1, 2, put a dot right there. And I do recommend on graphing inequalities to go from one side of your graph all the way to the other side. Okay, so extend your line using that pattern of the slope. Anyway, before I graph, the 2 extra steps, right? If it said equal, you'd put a line and you're done. But the 2 extra steps are, is it a solid line or a dotted line? What is it? Dotted, right? So we're going to put a dotted line right through those dots. Put some arrows on it because it continues forever. And then the extra step, the second extra step, is to shade. Do you shade above or below, according to this y being less than? Above or below? What do you say? Below. Y is less than. On your y's, whatever value you're at, the less than would be below, not above. A greater than would be above. So you could put your pencil on any part of this line. I want to put it on this red dot right here. And below would be this way. So I already know I need to shade everything on that side where my yellow line's at. So I need to shade in all this. And that's it. What does that mean? If I pick any coordinate in the shaded area, like 1, 2, 3, 4, 1. If I plug in a 4 and a 1 for x and y, plug in a 4 right there and a 1 right there, 4, 1, that'll give me a true statement. How do I know? Because it's in the shaded area. The shaded area represents all the answers that work. Everything that's not in the shaded area will not work. Okay? So if I were to pick any coordinate on this side and I plugged in the x and the y for any coordinate that's not in the shaded area, that will not work. Okay? And I don't know, if you have a highlighter, it might be good to highlight this entire side. But whatever. Anyway, number 3, I want to get y by itself. What do? I divide by -3. Keep in mind that there's an invisible 1 in front of the x. So your new slope-intercept form inequality is y is what? Less than or equal to or greater than or equal to? I change it, right? Because I'm dividing by a negative, it has to be a greater than or equal to the slope. I don't want a negative on the run, so I'm going to move that negative up to the top. So my slope is going to be a -1 over +3 with an x right next to it. And the b value over here, a -9 divided by a -3, is a +3. So it's now ready to graph. We're going to go to the b value of +3, put a dot right there. And then from that dot, I'm going to drop 1 and run 3. I'm going down 1 because it's a negative fraction. If it were positive, I'd be going up. Because it's negative, I'm going down. So down 1 over 1, 2, 3, and put a dot right there. And then I asked and we could go backwards too. Instead of just down 1 over 3, go backwards over 3, up 1, over 1, 2, 3, up 1, and put a dot right there. That way you extend it to the other side as well. Then the 2 extra steps. Is this a solid line or a dotted line? Solid. Why? Because it has a solid line underneath it. So draw a solid line right through those dots. Put some arrows on it. And now we need to shade either above this blue solid line or below the blue solid line. What do you say? Above or below? What does it say? Y is what? Greater than. Which way is greater than on the y? Is it above or is it below? It's above. So we're going to shade in above. Really that simple. Put your pencil on that line and just draw a line going up, a bunch of lines going up from that blue line. Again, that represents the solutions. Any point up here, like if I pick the point 0, 5, it's going to work. If I pick the point 3, 4, it's going to work. Any point up here in the shaded area will work when you plug it in. Any point in the non-shaded area will not work. Up here are the solutions, and there's an infinite amount of them. Down here, there are no solutions. Okay. There's only one more type of question that might confuse you. It's so easy that it might confuse you. Let's check it out. You don't really have this on your paper. Just pay attention right here. I hope we remember that when you have a single letter and a number, when graphing, let's go back to this fact that we've already learned. If x equals a number, it's a vertical line crossing the x-axis at that value. If it's y equals a number, it's a horizontal line crossing the y-axis at that value. So let's say I had an xy plane, and let's say my equation, they asked me to graph x equals, let's say, 3, yeah? So what would I do? I'd go to the x-axis, I'd go to 3, 1, 2, 3. I'd put a dot right there, and it'd be a vertical line going right through that x value of 3. I hope we remember that. Or let's say I asked you to graph y equals -4, okay? Then, on graphing y equals -4, you would go to the y-axis, and you go to -4, -1, 2, 3, 4, and you would draw a horizontal line going right through that y value of -4. You guys remember that from before? I hope so. X equals a number is a vertical line crossing the x-axis right through that value. Y equals a number is a horizontal line crossing the y-axis right through that value. So now that you understand or remember that stuff from before, let's take a look at an inequality that just involves one letter and one number. So right here we have x is greater than or equal to 2. So we know that x and 2, that's going to be a vertical line crossing the x-axis at that value of 2. So we go to the x-axis, we go to 2, put a dot there, and we're going to draw a vertical line right through it. But because it's an inequality, is this going to be a solid line or a dotted line? Solid line, because it does have a solid line underneath it. So I'm going to do a solid line. Okay, now I need to shade either above or below. But what the heck? What do you mean? That concept of shading above or below, that shortcut was only because y was by itself. Remember, we had like Y is greater than something, or that'd be above that value. Y is less than something, that's below that Y value. Why? Because the Y is up and down. Now, this doesn't even have a Y. It has an X. So we need to go back to thinking about X, which is left and right. So this says X is what? Greater than 2. Greater than is to the left or to the right? To the right. So you would be shading everything on the right side of this blue line. Now, you don't have this question on your worksheet, but if you do flip your worksheet over to the homework page, you do have number 5, and that's Y is less than -1. And that's right along with what we've been saying. Y and a number like -1, you're going to go to the Y-axis. You're going to go to that value, -1. You're going to put a dot there. You're going to draw a horizontal line right through it. But before I draw it, is that a solid line or a dotted line? Dotted. So we're going to do a dotted horizontal line going right through it. And then I need a shade. Do I shade above this blue dotted line or below this blue dotted line? Below. So you shade below. And that's the correct answer for number 5. Okay? So we do have this entire page of practice. Pretty simple. Make sure it's in slope-intercept form. After you got it in slope-intercept form, if it's ready to graph, ask yourself if it's solid or dotted. Of course, if you don't have a solid line underneath it, it's not going to be solid. If you do have a solid line underneath it, it will be solid. And then after that, you shade. Once you have Y by itself, if it's less than, you'd shade below. If it's greater than, you would shade above. Okay? So let's work on this. The answers are on Google Classroom. Check your answers as you go. And this will be on the test Friday, in addition to solving inequalities that we did last week.